OSI, Open System Interconnect. So most of you are in your academics, you may learn about a OSI model, mainly for CSC people, ECE people, okay, ENTC may having this OSI model, right, in networking course. So little bit different approach, what I am going to do is, but some are mostly common. OSI, Open System Interconnect. Interconnect means connecting, right? To connecting, communication, interconnection. Okay. Open system means any system, irrespective of what hardware you are using. Okay. Irrespective of what operating system you are using, irrespective of what application you are using, how to connect and communicate between the devices. This model explains that one. Okay. And OSI model is a networking model. It's a reference model. That's a open system model it is. Okay. So no proprietary, no vendorship. To use OSI model, no need to take any license kind of stuff. Okay. Next, networking model. Guys, we have different networking models. We are not using OSI model. Actually, we are using a TCP IP model. We are using TCP IP model. Networking model, what we are using, TCP IP model, transmission control protocol, internet protocol. That model we are all using. Not only that one, there is other models also available. IPX, SPX, IBM models it is, Novel Network, Apple Talk. So different networking models also available. Certain networking models only for that specific organization purpose only, or that specific organization network purpose only. Okay. So in a globally, we are all using TCP IP models. These models, all these models came before OSI model. Then what is this OSI model? OSI model understand different networking models and created as a reference model. So with the help of OSI model understanding, if you understand OSI model, you can create a network. You can create and maintain the network. You can create a network. You maintain the network. You can troubleshoot network related issues with the help of OSI model understanding. Okay, with the help of understanding. So the model of network can be anything, generally TCP IP, or maybe it is any other network model you are using. But to troubleshoot the network related issues, to maintain the network, it is better to understand OSI model first. Okay. So what are we are going to discuss about a OSI model with respect to of TCP IP model, because we do not have any idea about other models, their protocols, their logical addresses. We don't understand that, those kind of, we don't know about it. We know the TCP IP. According to TCP IP only, we discuss the OSI model. This OSI model created in the 7-layer type. Interconnection of these 7 layers is our OSI model. So how many layers? 7 layers. That's why it is called a 7-layer model. This model also standardized model. This is also we call it as a standardized model. And it is standardized by ISO, International Organization for Standardization. It comes under IEEE 802 general only. Okay, almost all networking related everything comes under IEEE 802. Okay. Next, what are these 7 layers? Guys, already I told in our academics, you may learn about OSI model. Some of you remember this OSI model, 7 layers like this: application layer, presentation, session, transport, network, data link, and physical layers. Some of you learn and remember this OSI model like this: physical layer, data link layer, network layer, transport, session, presentation, and application. So Which one is correct way? From application to physical, physical to application. Both are right. Both are right. Only thing is, when you are communicating, means you are sending. When you are sending, so start with application, end with the physical. When you are receiving, you receive to physical layer and it will go up to the application layer. You are able to view things from the application layer. Things will go out of your system through physical layer, like a NIC cards, okay, cables, Wi-Fi connections, this physical layer. And application, your browser from your web browser, or maybe your Putty applications, right? So different application views to communicate. Outlook for sending mails, okay? So this is mail communication. Outlook based. Again, okay. So if you remember the OSI model, like a physical layer, data link, network, transport, session, presentation, and application, like that only you remember, tell that like that only, no problem at all. Or otherwise, if you remember application, presentations, transport, network, data link layer, physical layer, keep it like that only. Or you forget, you remember OSI model, half of it only. Then try to remember, try to practice from application to physical layer only. Once again, guys, no need to turn on your mic, but tell along with me. So application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. These are the 7 layers. This layer 7 is application layer, layer 6 is presentation layer, layer 5 is session layer 4 is transport layer 3 is network layer 2 is data link layer 1 is physical layer. The layer numbers are reverse. So layer 1 is physical layer 7 is application layer. Again, application, presentation, session, transport, network, data link, and physical layer. These top layers means application, presentation, session, transport comes under software layers. Top layers, software layers. Bottom, network, data link, and physical layer comes under bottom layer layers. Those are called the hardware layers. The middle one is the transport layer is called as heart of OSI model. It provides end-to-end connectivity. And when we discuss about hardware devices, hub switches, routers, and that time we told that a hub comes under layer 1 device. This is example of hardware, example of physical layer is hub. Hub comes under physical layer 1. Switch comes under layer 2, data link layer. Router comes under layer 3, network layer. These are the 7 layers. And one by one layer, we'll go into see in we have less time, so I'm directly tell. So instead of drawing and writing, or otherwise we can draw. I can draw. Okay. The first thing is application layer, right? What is application layer? Guys, to communicate in the network, use an application, right? You use an application from your side means it's a client application you are using. Okay. You are sending, receiving through your client application. Example, web browser. Through web browser, you are accessing website. So web browser is a application. So application layer is about what application you are using for that specific communication. Okay, it's like a user interface type on it. User access. Okay, what is a we access our communication things through an application. Application is all about application. And in that application, again, to communicate to someone, so we use their address and protocols, right? So protocols also responsible in application layer. So application layer is all about application, what application you use to communicate in the network and what protocol you use for that type of communication. So protocols, because we are already discussed that separately. So I'm not going to specify what protocol here. Like you are accessing website, we use web browser. HTTP or HTTPS protocol. You're sending and receiving mail. Use Outlook application. Okay, use an Outlook application for sending and receiving mails, and use the protocol is SMTP, IMAP, or POP3 protocols. You want to access remote system, remote Linux system, for example. Use Putty application, and protocol is SSH protocol. You want to upload or download a file, we use FTP client application, FTP protocol. So in application layer, we are deciding for based on what communication, what application we should use it, what protocol we use it. So what is our destination address? Okay. So these are the things. This is I'm talking in a client side. What about a other side? One side I'm talking when I'm sending. What about receiving side or client side or receiving side? You're accessing a website. You're a client, you're accessing a website. Web browser is a web client application. So there is a web server application is there which process your request, understand your request, process your request, and provide a response to you. That is a web server, right? That is web server applications also. Apache, HTTPD, Tomcat, NGINX, Glassfish, Microsoft IIS. These are all different web applications. And Outlook, mail client application for sending mails. So our other side, mail server applications are there to understand what is your request and process your request by that application at other side. Example, Microsoft Exchange application, Zimbra, Postfix, Dovcat, like that one. Putty is an application. We use a Putty, and in a Putty we use SSH protocol to connect remote system. In remote system, SSH server understand your SSH request, and then it process your request and provide a connected to your system. Means you are sending, and other side it understand your request, process your request, and providing information again, right? This is application layer. In both end of the devices, there we are using an application layer to communicate. Okay. So in our system, web browser is very important to access website. In other side, that system, their web application server is important to process your request. Okay, to deliver the pages, who will give it? Directly system cannot give you. In that system, web server application understand your request, then it will provide that related web pages to you. This is very, very important to understand about. First part is OSI model. Okay, not blind. This is simple, straight. This is application layer. Understand, guys? Application layer. Next is presentation layer. Before you go to the presentation layer, in application layer, so what is your request? What application you are using? You see, you open an application, you put a destination address, and you specify the protocol and send the request. Other side also same thing. They receive a request, process, put it to the destination address, put the protocol inside, and send. Right. This is your data. This is sending a data from here in an application layer. Either you are sending request or you're giving responses. Whatever it is, it's a data only. In this layer data, the layer data we call it as PDU. The layer wise data we call it as PDU, packet data unit. It means every layer there is a data. There is a layer data is there that we call it as PDU. In application layer, the PDU name is data. In application layer, the PDU is called a data. It is nothing, no modification, nothing inside. So simple, we call it as a data. Presentation layer. Now the data is ready. So what is this presentation layer will do it? It take the data, convert the data, whatever the data format it is, it convert the data into ASCII format. This is called the encoding, decoding. Encoding, decoding. It convert the data into ASCII format. Encoding, convert any form of data into ASCII format. Okay, that is encoding. Decoding means ASCII format to normal format. When you are sending, you encode the data. So convert the data into ASCII format. Next, compress the data. So what are the data size it is, try to compress. So then it is easy to transfer to the network. So it will try to compress the data. When we are sending, we compress it. When you're receiving, decompress the data. Encrypting, decrypting. Encrypting, decrypting. So when you are sending a data, so data need to be encrypted based on your protocol. So we require to encrypt the data. So while you are sending data, so we encrypt the data and send it. And decrypt when it is received. So this is your presentation layer. What presentation we do? Encoding, decoding, compression, decompression, encryption, decryption. In your interview, if the interviewer asks direct question, what is the presentation layer do? It's a very easy to answer because direct answer it is three things: encoding, decoding, compression, decompression, okay, encryption, decryption. Okay, so we encrypt the data, sorry, we encode the data, compress the data, and encrypt the data is by presentation layer window. What is the PDU of presentation after encryption? What's the data? What is the PDU? Packet data. What is the layer-wise data is called data only, nothing more. It's a complete set of data, nothing changes inside. Only it is changed to ASCII format, then compressed, then encrypted. Nothing changes inside. Data is data only. Next is session layer. Session layer only one line, but actually it is session layer is very, very important. The session layer create a session, maintain the session, terminate the session. And session layer also do authentication and authorization. It carries the authentication and authorization information also. Okay. What is the session layer? For example, I open a website. So I open a browser, I put a website like this. So now our system create a session on it. A session ID is created. It attach that session ID to our data. Session ID indicating means when I'm sending this information to the remote system received it and send it back to the reply to your system, right? But where it has to be displayed from your system, you are sending. It may not display on this browser tab, or maybe it can be shown on the other browser tab. Maybe it comes and showing on this place. Any possibilities there, right? How it will understand? It has to be come to this part only, not onto anyone. So session ID. So what application? What's the tab? What is this session? What is the session ID? So as long as this browser tab is open, that the entire transaction, sending, receiving, entire transaction till the entire transaction completed, the session will be maintained. Once transaction completed, session will be terminated. Okay. So it maintain the session. It will create a session whenever you sending any data. Maybe you are doing ping command. The ping reply go to the browser. No, right? It won't go. Right? When you're doing pinging, are you doing SSH connection, or maybe you're sending mail connection. So whatever it is type of communication, from where you are doing communication, from which application you are doing communication, which tab you are doing the communication. So they, in that one only, it should become, it should be done the transaction. Once it is completed, it will terminate. That's it. Okay. So simple example, guys. While you are doing anything, you are purchasing anything from Amazon, Flipkart, or anything, or maybe you are doing some QR code payment, or you are sending money to someone. So you are connected to net, your Wi-Fi or 4G or 5G, you are connected, and you open an application and you give all the details, and finally you are doing transaction, right? So you got a OTP, you enter the bank details, you enter the amount, and you are got a OTP, and then just there is some time taken like 5 seconds, 10 seconds transaction process. Once done, it will show you transaction ID, transaction completed successfully. Entire this process must be done in the same session only. So when you open, session will be created. When you are started giving request, that enter request is tagged to the session ID. Entire transaction should be completed in a session ID. That's why when you do this, mainly this bank related transactions. In that browser tab or maybe in that application, it will shows. Do not close the application or a browser. Do not press the refresh. Do not press the back button. Why? While transaction, if you close and open the same application, your session will be changed. You refresh, session will be changed. Okay? Session will be changed. You press the back button and come back to same again, session will be changed. The session transaction get confused. Okay? When it is returning to your page, your session is not there. Your session is gone. A new session is created, does not understand where is your session. Sometimes that's why it is transaction successful, but the total placement of your order will be failure. Okay. In that cases, if it is notified that one, so definitely it will return your money. At least it is happened in a recent years, not recent, 10, 15 years. Almost we are getting that one. Earlier days, sometimes transaction failure, you may not get money back. You have to request the bank for transaction failures. Sometimes we don't know transaction successful or failure. Even it has happened to me when it is an IRCTC also. Okay. So session layer, what it will do? It add a session ID. It add a session ID to your data. And because of this session ID, we can understand, like a remote system will understand, complete the entire transaction. Sending, receiving will be done in the same session only. What is the next one? Transport layer. Yes, transport layer, one of the big layer compared to all other layers. Transport layer will take a time. But I will try max to max of that. Transport layer, the main transport layer, first one is, it is out of OSI model. We know it is provide end-to-end connectivity. In transport layer, it take this data, take the data and chop the data into small pieces. Okay. So what are the data from the session layer? It chop the data into small pieces. You chop the data into small pieces. This small piece data, we call it as segment. The chopping of data. We chop the data into small pieces. That is called as segmenting. The process, we call it as segmenting. The pieces is a segmented data. Okay, we chop the data into small pieces. That is called a segmenting. The process, we call it as segment. It segments the data. So this is small pieces is segmented data. So this is a segmented data. This is a one segmented data, segmented data, segmented data, segmented. So it is, we are having multiple segmented data in the transport layer. So one data is become multiple segmented data are there. So in transport layer, this is the first part. Chop the data into small pieces. This process called as segmenting. The pieces we called as segmented data. This is a segmented data. In transport layer, it add the few things to this segmented data. This adding is called a TCP header. TCP header. To segmented data, we are adding TCP header. What is the content of TCP header? What is in the TCP header? What is the segment? This segment is there in a segmented data. What is that segmented data number? Sequence number, numbering and sequencing. So once data is segmented into several pieces, it is our transport layer put a number on it. Transport layer put a numbers on it. So sequence number, segment, sequence number, arrange 1, 2, 3, 4 like that. What is the segment sequence number? Okay. Next, how many segments are packets you are sending to destination. That is called a window size. That is called a window size. We are adding segment number. Window size means how many packets we are sending in this transaction, or number of segments we are sending in this transaction. Next, we are already discussed protocols, right? In these protocols, we have a TCP and UDP type protocols are there. And what is the TCP, source and destination protocols, port numbers, source protocols, port number, destination protocol, port numbers. In TCP and UDP manner, it is added. So what is it? TCP type protocols, source port numbers, destination port number. Protocols, their source port number, destination port number is added to your segmented data. Okay. So now this total is become segment. So what is a segment? Segment contains segmented data, means chopped data plus TCP header. TCP header contains the segmented data's numbering and sequencing, sequence number. Window size means number of segments we are sending or a number of packets we are sending. TCP protocols, source port number, destination port number. UDP protocol, source port number, destination port number is added to your segmented data. The total PDU, the PDU of the TCP transport layer is called a segment. Now, transport layer PDU is called a segment. Okay. Okay. One thing we have to discuss is TCP and UDP difference. This is again TCP UDP is the most frequently asked question. Okay. After OSI model, TCP UDP is again most frequently asked question. Difference between TCP and UDP. Guys, earlier we discussed different protocols, right? Some protocols are TCP type, some are UDP type protocol. TCP, Transmission Control Protocol, UDP, User Datagram Protocol. Some protocols are TCP type. Example, HTTP, FTP, okay, SMTP. These are TCP type protocol. Lot of TCP type protocols are there. Some protocols are UDP. Okay. Example, DHCP, TFTP. You know, there is one protocol called DNS, not only one, but common protocol. So example protocol. So DNS is both TCP and UDP because in a different layers of DNS name resolution, it act as a TCP. Sometimes it act as a UDP in different layers of communication. Means from your system to local DNS server, local DNS server to your ISP forwarder, forwarder to root DNS server. So in a different places, DNS name resolution works. Okay, direct name server, indirect name server, cache name servers also there. So in different places, DNS works as a TCP, DNS works as UDP. Okay. Anyway, guys, different protocols are there. These different protocols, some protocols are TCP type protocols, some are UDP type protocols. If protocol is TCP type protocol, what happens? TCP type protocols are reliable. Reliable. The UDP protocols are non-reliable. TCP protocols are reliable. UDP type protocols are non-reliable. TCP type protocols are connection oriented. What is connection oriented? People saying connection oriented means wide. No, guys, it is not wide or wireless. Okay. protocol is connection oriented. Connectionless meaning is it verify the destination is available or not. Connection oriented means TCP type protocols will check destination is available or not. If destination is available, sync. Okay, source and destination are synced. Then only it will deliver the packets. That is connection oriented. Okay, connectionless. UDP protocols don't check destination is available, sync or not sync. It won't check it. It simply send the packet, destination received, not received, we don't worry. Generally, broadcast based messages. Okay, multicast based communication, broadcast based communications, or we don't check the destination available. We broadcast it. That's it. Destination received or not, we don't know. TCP type protocol, reliable, connection oriented. Acknowledgement based. In TCP, we use acknowledgement. So this acknowledgement means when you are sending a data source to destination, when you are sending a data to destination, the destination received and provide an acknowledgement. So it will send an acknowledgement to the source. When source understand destination is received. So source send a packet to destination. The destination received a packet and send an acknowledgement. So source received an acknowledgement from the destination. Source think destination is received. Packet is received. Source send packet to destination. The destination may not received and but source not received acknowledgement. Source is not received acknowledgement from the destination. Obviously, source thing destination is not received. If source not received an acknowledgement, then source thing destination is not received. Source received an acknowledgement, source thing packet is received by destination. If source not received an acknowledgement from the destination, it will send that packet again. It send the packet again. Okay, that's why it is chopping. So entire packet you can't, entire data you can't send. Small piece of data you are sending, destination received it, and it will give acknowledgement. We can understand it is received, then it will send another packet. Is source destination source not received an acknowledgement from the destination. Source what it is thinking, okay, this particular packet not received by destination, so we have to send it again. So this is in a TCP. In UDP, it's a different. Source and destination. Source don't check the destination is available or not. It simply broadcast or multicast the packets. But once destination received a packet, it don't give any acknowledgement, no acknowledgement. Source will keep on sending a packet. The destination may not be received a packet. Source don't know. Source don't know destination is received or not. Okay. So in this case, okay. So destination, particular destination not received a packet. So it is loss of the data. But in the next deliveries, it may be reconstruct the data. But right now, we'll see that. Okay. And because of this in a UDP, in UDP, source not waiting for acknowledgement. So comparatively, TCP UDP is a fast. Comparatively, TCP UDP is fast, but not reliable. It is faster, but not reliable. Okay. Connectionless, no acknowledgement use. TCP is comparatively UDP. Compared to UDP, it is slower. Okay. But it is reliable, connection oriented, acknowledgement based. Most frequently asked question in interview, guys. TCP UDP. Guys, understand TCP UDP?
Yes, sir.
Very good, very good. Network layer. Now you got a segment, right? So each part is a segmented part. So for each segmented data, we are adding TCP header. Then this is called a segment. In transport layer, several segments are created. In transport layer, several segments are created. For each segment, in network layer, we are adding source IP, destination IP address. The source IP and destination IP, we call it as network header. Network header means source IP, destination IP. This is called a routed protocols. In a OSI, logical address, we have to say logical address, source address, destination address is added. Okay, this is routed protocols are added. Means in TCP IP, as per TCP IP, we are using IP addresses. So we are telling it is source IP, destination IP is added. Plus routing information, routing protocol information also added. Means which way the packet has to be sent. Routing protocol information also means route path also you have to specify. Route path also we have to specify. This is our network header is added to your segment. This is we call it as packet. So in network layer, the PDU we call it as packet. So transport layer, several segments, each segment become a packet in transport network layer. Next is data link layer. In this data link layer, actually two layers are there. One is LLC, another one is MAC layer. LLC, logical link control layer it is. Two ways there is an explanation. One part is before whatever the network layer it is, there are software type based layers only. Okay. The packets, segments, every process done by our system only. Now in a reality, we are started getting connected to the physical. Okay, physical transmission will start from here. So that is a software transmission. This is a physical transmission. Physical connection, that is software process. To match this link between these two processes, software process and physical connection process. Okay, to match between this LLC will act as a bridge between upper layers to bottom layers. Means application presentation session transport network. Up to this one, complete database type one. But in data link layer and physical layer, there are connection based things. So that's why to match physical to software based layers, this LLC will work. This is one. What is the second one is? In LLC, we're also having WAN protocols. Generally, WAN protocols are layer 2 protocols only. WAN protocols. It means I'm communicating to my remote device in my local. Okay, I'm accessing my remote system from my in a local network only. So I don't require WAN protocols here. But I'm accessing google.com, facebook.com, youtube.com. That is outside of my network, internet. So I need a WAN protocol to connect outside of my network to have to connect it to my ISP to outside I have to connect it, right? How I connected? I use WAN protocols. What are the WAN protocols are there? PPPP, point to point protocol. If you are using ACT, internet services, they'll use PPP OE, point to point or Ethernet. Ethernet is a LAN protocol. Point to point is a WAN protocol. So WAN link connected directly to the LAN. So that is the use PPP over Ethernet type. HDLC, the Cisco, we use HDLC for WAN communication purpose. Okay, frame relay also WAN protocols only. Frame relay circuits are there. Using that, we are connecting through WAN. Okay, MPLS, multi-protocol connector it is. Generally, nowadays in organizations, they are using MPLS, multi-layer protocols are used. Different type of communication like voice or IP, one layer, regular data transmission, another layer. System synchronization like database synchronization, data synchronization, data transmission, another protocol. Video conferencing, another type of layer we are using. It is based on the QoS, quality of services. And what is another one? SD-WANs. Now we are all using SD-WAN. SD-WAN means managing WAN protocols, different WAN protocols used by an organization. We can manage these different WAN protocols, WAN connections in through software. Through software, we are managing WAN protocols, not just commands and simple diagram. It is through software visually we can able to see and manage this entire WAN protocols, that is SD-WANs. Okay, this is about LLC. 2 points I said now, connecting upper software layers to bottom physical connection, LLC use. And you are connecting over internet, over WAN communication. We use WAN protocol. WAN protocol will be added at LLC in data link layer. Two layers are there, LLC layer and MAC layer. We know the MAC layer, media access control. It is also called as physical address. MAC address is also called as physical address. Source MAC address, destination MAC address, and your packet and CRC. What is CRC? Cyclic redundancy check. What is CRC? It is an algorithm. CRC is a cyclic redundancy check. It is an algorithm. It generated data from your actual data, from your packet data only. It generated data. Okay, it's a frame data, FRC, frame data it is. This frame data, what it is, CRC generate a checksum data. This checksum data, okay, frame checksum data it is. So checksum data, use it for error checking. Means in data link layer, error checking is happens. This to source MAC address, destination MAC address called a network tail. Sorry, network head, sorry. Data header. The checksum data which is we are adding after packet is data tail. The total we call it as frame. So from data link layer, your packet now it is frame. Means it is source MAC address, destination MAC address, and your CRC checksum data is added. Now it is called frame. So frame checksum data. What is the purpose of CRC? For error checking purpose. Finally, we go to the physical layer. What is the use of physical layer? It converts your frame into bit stream. It convert the frame into bit stream. Guys, I said source MAC address, destination MAC. If you are using regular NICs like Ethernet cards, Wi-Fi adapters, it convert into the, if we are adding MAC address because NIC is having that NIC is having MAC address. In case you are using fiber optical connection, you are using HBA controller. Your NIC is a HBA. Okay, so HBA do not have MAC address. It has a worldwide name, not web, worldwide name, WWN. So that will comes here. Okay, I've written MAC address because generally we are all using either Ethernet, fast Ethernet, gigabit Ethernet, or Wi-Fi adapters we are using. These are all adapters having Ethernet based adapters only. These are all. So it is having MAC address. Very simple difference is regular LAN based Ethernet like switches or Ethernet, fast Ethernet, gigabit Ethernet, RJ45 connector, cable connector. It works based on CSMA by CD. CSMA by CD. Carrier sense multiple access. collision detection based algorithm runs it is inside. Wi-Fi, same concept. It is also Ethernet based Wi-Fi only, but wireless connectivity with 2.4 gigahertz or 5 gigahertz based connection it will provide it. It works based on the CSMA by CA, not CD, CA. Okay, carrier sense multiple access, CA, collision avoidance. So that is CD, this is CA, collision detection, collision avoidance. Okay. Okay, whatever it is your frame convert into bit stream, then bit stream convert into the signal. What signal? Depends upon physical media. Depends upon physical media we are using. For example, you are using Ethernet card, Ethernet, fast Ethernet, gigabit Ethernet we are using. So using cables like UTP, STP based cables you are connected, right? It is become electrical signal. Your bit stream become signal, which stream electrical signal. Okay, or radio wave signal. When it is convert radio signal, your interface is Wi-Fi adapter. It convert into light waves when if you are using HBA, means fiber optical connection. Okay, so this is how it is converts. So guys, this is about your OSI model: application layer, presentation layer, session layer, transport layer, network layer. Okay, and data link layer, physical layer, TCP/IP protocols, TCP and UDP differences. Of course, there is a few more things to discuss. How should both side communication happen between the two systems? How the communication happens, sending and receiving, comparing OSI model with the TCP/IP model, and how use the OSI model for troubleshooting. How to use OSI model for troubleshooting. Networking commands also there. Ping and trace RT command. Using ping command, how you troubleshoot network. But thing is, people are not showed up. I can't understand why it is. Morning time, we're very less time. We can't cover more. Afternoon, we can cover most. But what I'm doing is, we have a 10 to 15, 10 minutes. I will cover 2 points. We'll see that one. The very important is TCP/IP model, OSI model. Occasionally, also they're asking, explain about TCP/IP model or compare OSI to TCP/IP model. Now we'll see this. TCP/IP model actually came from DoD model, Department of Defense model. So TCP/IP model, it is a protocol suite. TCP/IP protocol suite or TCP/IP model. TCP/IP model, 4 layers only there, 4 layers. Application, transport, internet, network access layer. Application, transport, internet, network access layer. 4 layers are there. Okay, totally 4 layers are there. Okay, so here compare OSI model to TCP/IP model. So normally people think TCP/IP model having only 4 layers, OSI model having 7 layers. In reality, the function wise same. What are the OSI model do? Entire function done by TCP/IP. But layer names are different. Like little. In TCP/IP, application layer will do the OSI model, application, presentation, session. What are these 3 layers will do? It will be done by the application layer. Like in my browser only, application layer duties, right? In a web browser, application layer, protocols, it encrypt, decrypt, compression, decompression, session creations, session maintenance, session terminations are happen at a application layer of OSI model, TCP/IP model only. And in TCP/IP transport layer, at a transport layer, so chopping off the data, segmenting the data, adding TCP header to segmented data. Okay, so that is same in the transport layer of TCP/IP. Same transport layer. Internet layer, TCP/IP internet layer, same as a network layer, adding source IP, destination IP, and routing information to your segmented data, segment to your segment. So then created a packet, right? So that's same as for both. Network access layer. In TCP/IP, network access layer is combination of two layers, data link layer, physical layer, adding source IP, destination IP, okay, CRC checksum data, okay, checksum framework frame checksum data, okay, frame checksum or a CRC data or checksum data, frame checksum data, any word you can use it for error correction purpose, and convert that frame data into bit stream, and convert the bit stream into the, based on the connectivity device, based on the physical connection, convert into that related signal. This entire process done by network access layer. Okay, this is OSI and TCP/IP comparison. Understand, guys, up to here? How many days will take this network layer? I'm getting bored also. This is 13 members. Okay. With help of OSI model, how to troubleshoot networking related issues, and how do you communicate between two devices. These two are also there. Because we cannot disconnect and reconnect it after 5 minutes. No, we can't do it. So I will do it. So 5-10 minutes, we'll complete this part also. Okay. Troubleshooting with a OSI model. Guys, questions may directly or maybe indirectly also there. So when you are doing network related issues, when there is a network related issues, how you troubleshoot. So we understand OSI model, all 7 layers. If you understand all 7 layers, how to start the troubleshooting, which area you will look into it based on the issue. For example, two systems are not communicating each other. So what you will do? You are unable to get connected. You are unable to communicate to any system. That is physical connection, possible physical connectivity. Check it connected or not. For example, my laptop connected through Wi-Fi. My remote desktop connected through wired connection. Make sure there is a connecting path is there or not. My laptop connected to Wi-Fi router connected to a switch. That's my system connected to that switch. That is a connecting path is there. Both are may not connected to same switch or may not connected to same Wi-Fi router, but there is a connection path is there. In our office, we have several switches are there. All these switches are interconnected. Connectivity is there. So my desktop is, the wire is went to up to this table wall plate. This is my desktop system. Through wire, it is connected here. And this is my Wi-Fi router. My Wi-Fi router LAN port is connected to this switch, and WAN port is connected outside of system, right? It's connected outside. Of course, before that one, there is a firewall. So through that, it is connected. Go to ISP. Modem part. This is WAN port, internet port. This is LAN port. Okay. And this is my laptop. Okay. Here I connected to Wi-Fi. So there is a path of connection. So if both systems unable to communicate each other, or you are unable to get connected or communicated, connectivity, check the connectivity, wired connectivity or wireless connectivity, check the connectivity. Very first point, any network troubleshooting, first thing is check the connection. And what is the second one? Check the IP address. You understand already IP address, network and host person. Two devices are in the same physically, logically same network means their logical address must be same. Host portion must be different. Means network portion must be same. Host portion is must be different. Or network ID must be same between the two systems. Check it both are configured with the proper IP address or not. Okay. Is their network ID same or not? Okay. That is check the IP address. Second one. Third one. I am able to access. So here I am trying to access my remote system. Sorry, mistake. Okay, yeah, I connected a SQL server in that remote system. Okay, so I'm accessing remote system from here. I'm not able to access. Okay, so I'm trying to connect a web page from this remote system, or I'm trying to access remote system using SSH. I'm trying to access certain services through this port number. I am not able to access. So who is controlling that port number access? Protocol or IP address is firewall. Maybe the system firewall is not allow you to access. Not allowed to access. How you troubleshoot? First of all, you have to check the make sure both systems are connected or not. Check the IP address. Third one is first connectivity. Basic connectivities there are not. Basically, both are able to communicate using ping or not. Even ping is not working. Also, we can establish connection is good, IP address is good, but not able to communicate or able to communicate. So what kind of reply? If you got a reply, then different reply. So we have to estimate something. See, now it is I'm getting destination host not reachable. If I got a destination not reachable, means either IP address is wrong. When I'm trying to reach my destination, either I given IP address wrong from my side, or destination IP address is somewhere different, or destination is down, disconnected. Destination host not reachable means either destination is down, disconnected, or you are giving IP address is wrong. IP address is wrong. Possible? Okay. So if you got a request timed out, in case you got a request timed out, so what is the possibility? You get a in case of request timed out. Here everything we will get it. Okay. If you got a request timed out, what is the situation? In request timed out, possibility is either the destination is not available, destination is disconnected, or destination is IP address is wrong. Possible, right? Plus, at destination, the firewall is not allow you protocol. Destination is not allowing you. So this is through HTTP I'm accessing, right? This is through HTTP I'm accessing. This is my remote server. What's that? 5 minutes. In case in this remote server, this HTTP is not allowed through firewall, I can't connect it. So if host systems are connected, IP is good, and you try to connect it using ping command. Based on that, you will get some kind of information. Both are communicating each other. But Butler service is not accessing. Butler service is not accessing. Then what to do? It can be firewall related issue. Check the firewall, and is firewall allowing your request or not? Your system IP address or network is allowed or not? Check the service is allowed or not in the firewall of that system. Next, you're accessing certain remote system. You're accessing a website or a mail communication, you are doing it, but it is not working. You use a ping command to check it. Through ping command, you confirm that both are connected, communication is there. But particular service not getting properly. It is showing not secure kind of stuff. So it can be security, SSH or SSL or TLS based encryption problem. Okay, either your SSH, your SSL certificate is expired also possible, or incompatible versions are there. Okay, 1 second, open filler. Okay, so this is a open filler application. I want images. When I connect this remote server, I am getting this error from last 3 years. Error SSL version or cipher mismatch. This type of errors I am receiving. Not like this. This is error in the cipher mismatching. So what could be the problem? Problem is that server, it is connected through HTTPS. So when it is connecting through HTTPS, SSL certification is there. That is expired, older certificate. So it is, you are getting these kind of issues. So when you are getting any SSL or TLS type of cipher issues, it means either the remote server SSL certificate is expired, or you are using your remote server, or you are using different time based on your time zone. Based on your time zone, you are using different time. So time mismatch is also possible in a presentation layer. Application layer. So as I said, application layer, I'm accessing this website, right? So in case this specific application is down, okay, this particular service is not running in the remote system, then also you can't able to access it. See this? I can't able to access. So why? Because of that remote server. The server is running good. The server is running good. So I'm able to access. Even the remote SSH also I'm able to connect it. But website I'm unable to connect it. What is the reason? That web service is stopped. The web service is stopped. Not start. Okay. So that particular services may not running, or that particular page is not available. That particular page is not available. Then we are getting this kind of situation. Okay. So you got a 404 error page, means that particular page is not available. I'm trying to open some web. Okay. So I put a one URL. I'm showing it is showing 404 page not found error. Sorry, like this it is showing. So what is the meaning? This particular page not available in this server. Okay, but server is running and other pages also running, but this specific page is not available. That's why it is showing 404 error messages. Okay, so based on what kind of error it is showing, also we can understand which layer possible situation, what is happened to the system, and which way we can able to troubleshoot. This is how the OSI model help us to understand what is an issue and where to check that issue related and how to resolve the issues. Okay, so this is about your OSI model. That's it, guys. And of course, based on your interest, This is just read it and check it. Already I told ping command, troubleshooting ping command and all. So check that one. So tomorrow we'll start the new topic. That's it for today, guys. I am also stopped it.